All right. Hello, everybody. Welcome. This is our first lesson in Chapter 7. And in Chapter 7, we're going to be talking a lot about exponents and a lot of the properties that govern those things. By the end of this first lesson, there should be 4 videos here. You will be able to use the product of powers property to multiply variables, and you will also be able to use the power of a power property to take an exponent to another power. So let's go ahead and jump straight into it. So multiplying variables, I want to kind of jump back a little bit here and have you guys think about just multiplication in general, right? When I say what is 3 times 2, right? We know because we're very well practiced and and we're freshmen in high school or whatever you are, and we know that that's 6, right? But what we're really doing when we multiply is taking this number 3 and adding it to itself twice, right? It's like 3 times 5 is really 3 plus 3 plus 3 plus 3 plus 3. We don't write 5 3s because that's really annoying to do. And so we came up with this shorthand that if we're going to add the same number to itself multiple times, we multiply them. Okay, and so we know that that's 15 because 3 plus 3 plus 3 plus 3 plus 3 is also 15. Okay. This same logic applies when we move to variables, right? When I write 5x, we know that that's 5 times x. And what that really says is we're taking that x and we are adding it to itself 5 times. And while I don't know what x is, I know that 5x is going to be that number added to itself 5 times. Okay? Well, this logic that we use with repeated addition, right? This is what this is. It's called repeated addition. This logic we can extend to what we have as an exponent, okay? 3 squared, right? Remember this thing up here, it's called an exponent, or sometimes known as a power. They are the same thing. What that tells us is instead of repeated addition, it tells us repeated multiplication. So 3 squared is really 3 times 3, right? And 3 to the 5th is 3 times 3 times 3 times 3 times 3, right? It's the same idea, but it is, instead of it being repeated addition, the exponents represent repeated multiplication. So again, when we have x to the 5th, what that's really saying is x times x times x times x times x. I don't know what x is, but I know that I'm going to multiply it by itself 5 times, right? It is repeated multiplication. Now, that's going to help us when we need to multiply variables together, right? So think about that logic, that x to the 5th is really x times x times x times x times x. So how would we go about doing x to the 3rd times x to the 7th, right? Notice that we're multiplying these two variables together. Well, I know one way that I can do it. I could take this x to the 3rd and I can make it x times x times x. And then I need to multiply that by this one, which I could make x times x times x times x times x times x times x. That's 7 x's, right? Yep. Okay. And then how many times did I really multiply x together? Well, I multiplied it by itself 3 times here, and then I multiplied that by itself 7 times here. So this is 3 plus 7 makes x to the 10th. And as it turns out, that is a very nice pattern, okay? And that pattern always holds when we multiply variables together, right? If I'm multiplying things of the same base, right? These are both x's. I know that instead of writing this whole thing out, which is really long and frustrating, I can simply add the two exponents together to get x to the 10th. In general, what we can say is that a to the m times a to the n equals a to the m plus n, right? And we call that the property of multiplication. Or no, that's not what we call it. What do we call it? I forget the name of it, right? It's not important. It's not important. Here, I'll back it up. It's in the. It was in our goals, right? Product of powers property. There we go. Right. Oops, I messed up my cursor. The product of powers property is what we call this thing, and all it tells us is that if I'm multiplying two things of the same base, I simply add the exponents together. So we can use that property to do some examples. So 7 to the third times 7 to the fifth. The base here is the same. So this is simply 7 to the 3 plus 5, which is 7 to the 8th power. Now, we can finish solving that, right? I could take a calculator and do 7 to the 8th power, which, by the way, if you're doing that on a calculator, there's a button on calculators that looks like a little up arrow. It's called a caret. That's how you would find that number. For the purposes of this assignment and some future assignments, this is an okay answer, right? This is called exponent notation. It is okay to have it in exponent notation. Oops, let's spell notation correctly. Notation. There we go. And so that's okay. 7 to the 8th power because I added the 3 plus 5. How about this one? We have 9 times 9 to the 8th times 9 squared. Well, this is 9 once. So that's an important thing to remember. If you don't see an exponent, there's a 1 there. And then there's 9 to the 8th times 9 squared. This is 9 to the 1 plus 8 plus 2, which is 9 to the 11th. Whoa, that's a funny looking 11. Yeah, kind of there. And then part C here, -5 times -5 to the 6. Remember, this is -5 times -5 6 times, which means we've got -5 to the 1 plus 6. Again, there's no exponent here, which means there's a 1 right there. So this is 1 plus 6, or -5 to the 7th power. Notice how I've kept the parentheses here, right? The parentheses. They are an important thing in this problem, because if you don't have the parentheses, it's negative times 5 to the 7th, and that's a different thing. And we'll show that later. So there we go. 1 plus 6. Same base, add the exponents. Finally, x to the 4th times x to the 3rd is x to the 4 plus 3, which is x to the 7th power. So again, if the bases are the same, we can, instead of writing this all out and doing it repeatedly, we can simply add the exponents. And that concludes our first video here on the product of powers. On your Canvas lesson and on your note sheets, there are some problems that I'd like you to try on your own. I will do some examples at the beginning of the next video.